Good luck, Sarah.
Thanks.
Okay, participant pun dah 37. Macam mana? Ada time? Tak di start ke? Nak tunggu lagi 5 minit?
Kalau saya okey je. Cerita dia moderator kita ada ke? Saya tak nampak dan tak dengar.
Ada.
Okay. Silakan Nelly.
Okay. Assalamualaikum and good morning everyone. Welcome to the series of sharing session on research in physics. I am today's moderator, Nelly Shazwani binti Azman. It's a pleasure to see you here and I welcome all of you to this sharing session. Today you will be hearing to a presentation from Dr. Siti Sarah binti Safai from the Scientific Computing and Instrumentation Group. She has a bachelor degree in industrial physics, a master in applied physics and a PhD in experimental physics. Her research interests are plasma technology and fluctuation analysis. How are you today, Dr. Sarah?
Okay, good. Thank you.
Our next speaker is Dr. Nabilah binti Kasim from the Applied Optics Research Group. She took her bachelor degree in industrial physics in University Technology Malaysia UTM from 2007 to 2010. Then she took the fast track program of PhD in physics, also in UTM, since 2011 until 2015. Her research interests are ultrafast laser, saturable absorbers, Q switch, and mode lock fiber lasers. Dr. Nabila is not here right now.
Yeah,
So
as
it's
I
a
mentioned just
pleasure
now,
to have.
she's class. She has class.
Alright.
After this, she will
It's a
join
pleasure
us.
to have both of them in our sharing session today. Now moving on to our session. Please welcome Dr. Sarah, who will be speaking about what is her research group is all about.
Okay, thank you very much. Okay, I will share my video first. Okay, so okay, my side is simple. And then firstly, our group leader, Dr. Muhammad Firdaus, will present this slide, but he has some difficulty, so I will represent him to this slide. Okay, all right. So here our group name is Scientific Computing and Instrumentation. So our group focus on the simulation of computation and the technical expertise on electrical, electronic, and the instrumentation. So if you notice, our research core area is multidiscipline. So computation and instrumentation cannot stand alone. We need we use our expertise in computation and simulation to study other physical phenomena or other field. For example, here computational condensed matter physics is more to the material. So this is completely simulation. Computational nuclear physics, this is more to the nuclear, but this also completely computational. And nanostructure materials, this experimental. Thin film physics, experimental. Second, harmonic generation materials, vacuum science and instrumentation, medical device. We also have research about medical device and instrumentation, and space plasma physics by Dr. Suhaila, electromagnetic simulation using FDTD, ESA quantum computing by Dr. Yap, and plasma physics, me and Dr. Suhaila. So I forgot to introduce our member. We have 7 members, include associate of Dr. Amiruddin Syari, Associate Professor Dr. Abdul Kamil Ismail, Dr. Suhaila M. Buhari, and Dr. Yap Yun Zen, Dr. Razif Razali. This is me. And the last one is Dr. Koh Meng Hock. So Dr. Koh Meng Hock also in book in radiation, nuclear and radiation. So we have a collaborative partner, Center of Quantum Technologies, my lab, Rigaku, Chuan, Osaka University, National Meteorology Institute of Malaysia, and University Malaya, and Bilin Pilma. Okay, first and foremost, I will talk about Dr. Firdaus, our group leader in research. So his expertise in like electrical and electronic. So like this, variable high voltage DC power plus ER amplifier control system, indoor farming using LED. So this is his expertise in the electrical and then this is the research area. He also doing some research in the materials, multi-layer film application, epi-layer deposition, nanostructure fabrication, second harmonic generation glass, and okay, then this is the device or equipment. So this one PECVD, we call PECVD, and we have CVD, we don't have the picture here, and we also have thermal evaporator. We have thermal evaporator, ada hilang sikit. Thermal evaporator and sputtering. So this is kira equipment yang agak mahal, high maintenance equipment. So sometimes dia ada rosak, sometimes dia buat hal. So that's why kena ada skill lah dalam electrical electronic kalau in case tiba-tiba that one shut down. So this one characteristic for material, for example Raman, XRD, XRR, PL, FTIR, AFM, SEM. So this one for to characterize the material. So this is, for example, this is disc or silicon disc. This one we will put inside this vacuum or to deposit the material. So the deposition macam mana deposition tu berlaku, kita akan letak material, letak gas, dia akan gunakan different gas, so akan masuk ke dalam ni. So dia ada banyak apa ni, banyak input dia, ada input untuk power, ada input untuk gas, ada input untuk sensor. And this is the new one. It's the huge, very big vacuum. I don't know there. And normally kalau chamber macam ni, kita kena ada vacuum system. So vacuum system tu untuk memastikan untuk avoid any of the particle, unwanted particle yang ada dalam ni yang akan deposit atas kita punya wafer. Kita nak elakkan deposit dalam this wafer lah. So this one, this is indoor farming. Lepas tu dia juga interested in agriculture. So he is doing something with the Indofamim lah, LED. Okay, we move on to another one. Okay, Dr. Suhaila M. Buhari. She did PhD in space science. So the research interest is physics of the ionosphere, space weather, and solar terrestrial system. So she used the instrumentation. Instrumentation ni adalah quite global. I mean, maybe they have like centered in Malaysia. Bukan semua universiti lah ada this equipment. So observation using global navigation satellite system, satellite system, back radar, radio wave propagation, and optical imaging. And then research activities, space data analysis using MATLAB, Fortran, Python, and etc. So dia ada buat mapping to 2D maps of GPS disturbance due to ionospheric perturbation observed in Southeast Asia. So this is the magnetodynamics PhD simulation by NASA. And the solar wind adalah satu benda yang biasa terjadi, macam dia datang daripada sun. So plasma, maksudnya plasma is the meaning of plasma is ionized gas. So if we call it plasma kat mana-mana lah kita boleh jumpa, macam lampu, macam for example this one ionosphere, it's ion. It means the molecule is ionized. It's not in neutral condition. So kita ada ion dan electron. That's why we call plasma. So memanglah plasma ni ada two term. Satu lagi in bio, but sekarang kita fokus plasma in physics. Kalau bio, of course lah dalam blood cell apa semua kan. Plasma in term of physics, dia ada term lain lah. So dia ada dua meaning. So plasma is ionized gas. So any of the macam tadi untuk PCVD pun dipanggil plasma. Dalam tu bila gas tu dia akan ionize, dia akan panggil plasma. So normally kalau gas tu become plasma, dia akan ada cahaya, dia akan bertukar lah. Sometimes kita akan tengok dia punya physical phenomena apa semua. Macam sun ni plasma juga. So macam kalau argon dia akan warna purple, nitrogen akan warna pink, helium akan warna hijau. So depends on the gas lah, warna plasma ni. And then we go to Dr. Abdul Kamim Ismail, and he is the director of Department of Physics. The research area macam ada overlap dengan Dr. Firdaus. Dia ada bekerjasama lah dengan Dr. Firdaus. Okay. Nanostructure materials, nanowires, quantum dots, nanotubes, nanoflowers, nanocones, nanopillars, and nanosynthesis, growth and characterization, MEMS, sciences and fabrication, instrument and measurement. So brain signal recording and processing. And the last one is medical device. And Dr. Kamim memang dia punya expertise dia buat sensor. So kalau normally untuk final year project dia akan bagi projek yang berkaitan dengan sensor. And then of course kalau untuk sensor dia ada application jugalah. So some of the the sensor application. Another one dia buat medical device atau brain signal recording and signal. So this is brain sensor. Dia akan letak di seluruh kepala. Actually sensor ni adalah just kepingan plug, right? Electrode plug, besi, aluminium plug ke besi ke, dia just a simple plug lah. Dia boleh send electrical pulse dalam otak and kita boleh tengok apa dia punya. Normally kajian berkaitan dengan penyakit, berkaitan dengan stres, berkaitan dengan sometimes mungkin brain activity dia inducekan on like music, like different genre of music, and this one is the nano punya lah, characterization for the nanostructure material. And now we move on to Dr. Yap. So quantum computing using electron spin, resonance and superconducting qubit. All current computers are based on classical physics to process information. I am working on a new genre of computers called quantum computer QC. Quantum computers use energy states of a qubit to store and process information, which give rise in special effects such as superposition and entanglement. Z microwave plus at 8 GHz we control these qubits and perform various experiments. And then this is the application in quantum. They perform quantum chemistry simulation at unprecedented speed and accuracy. This molecular study and simulation. The application is simulation of new catalysts in the production of ammonia to reduce high cost of ammonia.
Sorry, Dr. Sarah.
Yes.
I would like to inform that we have international student here, so you might need to speak in full English.
Right.
And we have 5 more minutes.
Oh, okay.
Okay.
Ammonia is production, simulation of new chemical with identified beneficial traits can lead to faster and cheaper drug discovery. Significantly faster computing translates to less energy compared to classical supercomputers. Discovery of new materials for better batteries, significant contribution to artificial intelligence and optimization applications. So I think this is quite a challenging field. So for the Malaysia, we don't have this equipment, this equipment for experiment in Malaysia. If you want to do this experiment, you need to go to the Singapore or Japan, like Dr. Yap. He also fellow, active researcher fellow in Singapore and Japan, and he also control the experiment from here. He control using internet the experiment in Japan, so he can get result in Malaysia. So yeah, the cost is quite high. I think in Malaysia not much people do this research. And this is my research area. My research area of plasma applied in the seed treatment for pumpkin seed, honeydew seed, and all palm seed. And this is also can apply in the medical. So one recent article, they apply in the surface to to kill the COVID virus. And then I also done fluctuation analysis in my PhD. Actually, I applied in the dusty plasma. Dusty plasma is just the research areas to study the diffusion of particle. So when we plot the particle diffusion, we can get this graph. And then from there, I study the fluctuation analysis, and I will change the pressure. When I've changed the pressure, the diffusion of particle will change. Actually, I study the different phase from the crystal liquid to gas. So I study a different phase, and I study the motion of particle, and then from that one I get this graph and study using the fractal analysis. Okay, the last one is Dr. Koh Meng Hock. So Dr. Koh Meng Hock, the research interest is emergence of the deformed magic numbers for nuclear astrophysics applications, stability of super heavy elements, and impact of nuclear tensor on nuclear properties. So for your information, Dr. Koh Meng Hock does the research completely in the simulation. So and then he also have the collaboration from overseas, Ludovic Bonnet, the Center of Nuclear Studies, Gradinen, France, University Autonoma de Madrid, Spain, and University of Vietnam. Okay, so this is his major publication. So if you're interested in the nuclear physics, but this is nuclear physics, they don't have like optical. Sometimes you imagine the nuclear physics we have like optical device, but this one completely the using equation, simulation. So okay, I think that's all from me.
Very much, Dr. Sarah, for the very informative presentation. So, are there some questions from from the students? Okay, so I think I have a question for Dr. Sarah.
Okay.
So Dr. Sarah, as a researcher and also as a mom, is it hard to be a researcher? And as you showed us just now, the materials, instruments are kind of big. So is it hard?
Oh, okay. Okay, honestly, yeah, it's hard to be a researcher because we have to produce something new, something have novelty, different from the others. So every second in our life, they first produce something. So finding something. So every university like they like what so and then we need to be creative and innovative, and before we want to produce something we also need to study the literature review. We need to know what is the current technology, what is the current finding. So I think if we go to the if we set your mind to go for the research, that is the challenge. But for degree, I think it's okay.
Wow. Thank you, Dr. Sarah, for the inspiring sharing and talk. So let's move on to the next speaker, Dr. Nabila. Doctor, can you explain in detail what exactly your research group is all about? Dr. Nabila, how are you today?
Oh, hi.
Okay, how are you today, Dr. Nabila?
Hi, Alhamdulillah. Just wait, okay. I try to turn on my video. Okay. Can you see me? Can you hear and can you see me or not?
Yes, Doctor, we can hear and see.
Sorry. Boleh dengar saya kan?
Yes.
Boleh. Yes, Dr. Nabila. I can hear you.
Okay. Okay, I try to share the slide first. Okay. Okay, before in the meantime, while I open the slide, can you all just tell me what is your idea or your view about optic? Because I believe my team, research group, applied optic research group, is the last RG, right, to present. So previously you already heard about material, about nuclear, right? Can you guys just drop your idea there about optics? What I'm going to share with you all. Dia macam mana ke sekejap? Kan? Okay. Just mana slide saya? Kenapa tak naik slide saya?
For your questions, there are some students that answer. Hafiz said he remembers fiber optic, and Ni Ahmad said study on behavior of lights. Aina
Okay.
Amira said lasers.
Alright, okay. So thank you so much to Muhammad Hafizuddin, Ahmad, and also Aina Amira for your idea. So I will touch all of them in my presentation today. Before that, Assalamualaikum and a very good morning to all of you. First of all, thank you very much for having me in this talk. So I am the team member in the Applied Optic Research Group. So if you can see from here, we have 70 members. Here we have Associate Professor Dr. Kamal, Dr. Raja, Kamal Zaman Raja Ibrahim as the group leader. And so we have Associate Professor Dr. Hazli Bahtiar, Dr. Muhammad Arif Jalil, Dr. Noain Hussein, one of your lecturer right here, Dr. Fairuz Diana Ismail, me, and also Dr. Maisara Nuralim. Okay, so for Applied Optic Research Group, mainly what we study is about light. So it's not just the things that we can see, it's also something that we can investigate. For example, the material or something in the microscopic level, the things that we cannot see with our eyes, but we can see with the information in the spectrum given by the analysis by using light. Okay, So basically, the research core area in our team is about laser and optical instrumentation, high-speed optical imaging, laser interferometry, optical and fiber optic sensors, fiber laser system. Okay, we carry all of it here. And also, we have the some of advanced technology in terahertz spectrometry and imaging. Okay. Alright, so I will go through one by one each of team members' research project. Okay, so this is me, Dr. Nabila. Okay, so my research area and team is about ultra fast laser. So I cannot see your face. Okay, laser. What do you understand about laser? Just now Aina has right laser right in the chat box. Lasers. Aina or anyone? What do you understand about laser? I believe you have the subject wave, apa? Sound wave and optic, right? In year 1, semester 1. So what do you understand about laser? It is kind what type of light, but it's quite different because laser can have in either continuous wave or also pulse laser. Okay, so what I did in my research is actually I tried to generate pulse laser. So why we need pulse laser? Again, what we what we are doing in our research, we always question why we want to do it. Okay, so what is the application that we can approach in our research? So in mind, we have what different categories. So one of them is to generate the pulse laser. Okay, so pulse laser, why we want to generate pulse laser? Because of high demand lah, of course. Because continuous laser, if you learn about laser later on, because in physics we know the in material, you have heard previously, root material, okay, in the periodic table, we have a lot of elements in there, right? So the elements in the periodic table have their own character. It based on the, we call it the structure of the atom or the energy level for each element, okay? So different energy level translate to different application because they emit different wavelength of light. Okay, their electromagnetic spectrum. So if you can see from there, we have visible, infrared. Okay, invisible. Okay, so from there you will play in this area. For example, mine in my research. Okay, first I question what I want to do in which application. For example, in telecommunication. Okay, right now in telecommunication, for your information, the transmission wavelength is about how much? Anyone have the idea? It's about 1.5 micrometer region. So in this area, we other researchers have do their analysis for these different elements. And if you notice in the periodic table, okay, semua orang please open the periodic table. In the box below, okay, so there are the rare earth element. Okay, so rare earth element, or we call it lanthanide group. Okay, semua orang boleh google ya, boleh try to search the lanthanide group. And from there you can notice there are a lot of elements, and please find the word ER. ER is for erbium. Okay, so erbium, so when we have this element and we give light, for example, we have the element, this is the erbium, and we give light, light pass through this element, the erbium, and it will yield to transmission at 1.5 micron. So this transmission is very useful in telecommunication. How fast you can go. So if you can see in the advertisement, so many in TV as well, we are now moving to fiber optic. Because why? Okay, before we go to fiber optic, previously researcher they go open air laser, for example. So the drawback for open air laser is that it has a lot of elements to control, okay, the optical element to control, and also from there they might have a lot of loss. So the signal is not so strong, it's not so fast as well. So that's why we are using the fiber. Okay, so for example, this is the laser. That's now. So this is the laser that we use. Dr. Ain also expert in this fiber laser things. Okay, so this is the laser. We give them medium to pass through. For example, this is the light, so this is the fiber. So it is inside the fiber. So in the fiber itself, it has a core and cladding. Okay, so core and cladding ini yang you all belajar about total internal reflection, about transmission, about different refractive index. Okay, so it is the things that you learn actually in your degree. So you apply that, you do research, and you can get a good a good result in application. Okay, so that is your contribution to the industry lah later on. Okay, itu nanti talk about industry kot if you have that. Okay, then yang lain juga, other things that you can do is that the fabrication of this electrode absorber, because to produce the pulse laser, you can use either active or passive technique. Active technique is you use a lot of equipment like CSAM and all that. So it costs a lot of money as well. So that's why nowadays people move to fiber laser because it's easier to conduct, and also the signal we can have a very high power. Okay. Okay. How we can measure it is high power or not? Of course, by the output power, and then the other character of pulse laser is the repetition rate, the pulse width, and all that. So it is again actually the things that you learn in the optics topic. Okay, and then you apply that. Okay. So far, anyone interested in fiber optic? No. The moderator, so far okay or not before I proceed?
Ya, okey Doktor.
Okay.
Yeah.
Now I know optic much complicated is true, and what make it complicated if it's true? Question from YouTube. Complicated as in fabrication of the fiber itself, because yeah, the machine to do that cost millions of course, but then what we want is the output signal, because this output signal can contribute to so many applications. Because why people still use fiber if it is complicated? Because it can give a good output that we want. Okay, alright. Is that okay? Haziq ke siapa yang tanya tadi? Hazim. Okay, sorry. Salah pula pronoun nama dia. Alright. Okay. So that is about optic lah. Again, to do this, to synthesize the sectorable observer, you can again look at what are the application that you want. Just now I mentioned about the telecommunication, for example, 1.5. You can also make application at 1 micro region. 1 micro region is very beneficial for the, for example, a skin treatment, okay, for the LiDAR and so on. So that one you can use other materials such as ytterbium. Okay, 2 micron, for example, you can use thulium and so on. And all these things basically is again look at the energy level of each element that we use. Okay, because from there, laser you can absorb light and then transmit the required transmission that we want lah. Okay, so that is what I'm doing in my research. Next is Associate Professor Dr. Hazri Bahtiar. Okay, Dr. Hazri did his PhD in France. Okay, he can speak France. Okay, everyone. So it is the study about unconventional water electrolysis green hydrogen generators using green laser and magnetic field. Okay, so you can see from here is to perform lab scale electrolysis for hydrogen production under influence of optical and magnetic field. Again, sama when we study about the electromagnetic spectrum, we have both optical and magnetic field. Okay, so number two.
Could you try again?
What's that?
I'm not sure I understand.
Oh, sorry. It's my watch. Sorry. Okay. Then to study the effect and contribution of laser, magnet, and catalyst towards the hydrogen production efficiency. And third, to validate the percentage. To validate the percentage increment in hydrogen and production energy efficiency for the whole system. Okay, so what are the benefits of this study? It is good for Malaysia and also globally, impact to the international level. Okay, and then the achievement, why we do this study, because we want to reduce the carbon level, option for carbon-free hydrogen production from renewable and nuclear resources, right? And then Dr. Hazri also did study in effect of different silver nanoparticle shapes towards surface plasma resonance in fiber optic sensor. Okay, other than for fiber, other than we can use to produce a high output power in different micrometer region, we also can use it as a sensor, because how we can use it as a laser, because of the transmission signal that we get after we pass through the light. Okay, for example, here synthesis and characterize AU silver nanoparticle with different nanostructure, deposit and characterize different silver nanostructures on the sensing region of tapered optical fiber. Okay, so determine and optimize the TOF and SPR response optical fiber in terms of sensitivity, repeatability, response time, reversibility, stability, okay, under control environment, and also evaluate the sensing performance of aptamer based TOF and SPR sensor. Okay, uh, for fiber optic, we can, as I said just now, we have the fiber, we have core, and also, say for example, this is the core, okay, and this is the cladding. Okay, so this is the core and cladding, and we can gently remove this cladding. Okay, so what left is the core. Okay, so we can put whatever we want to investigate in this core and pass through the light, and we can see how it operates. It will diterjemahkan in the spectrum analysis. So from there, we can know what is happening in our material that we want to investigate. Alright? Okay, that is the example lah. Okay. For Dr. Raja, sorry, ada yang bercakap ke?
We have 5 more minutes.
5 more? 5 more minutes? Okay. Alright, so Dr. Raja did optical spectroscopy. This one is the decomposition of volatile organic compound using plasma. Again, plasma is the fourth state of ni. We know that we have solid, liquid, gas, and lastly is the plasma. Okay, fourth state of matter. And Dr. Raja also involved in the Sungai Kim Kim sample. Okay, so from there you take the sample, so you can determine what is the decomposition or the composition of the apa kita panggil, bahan yang kita tengok tu lah, right? Sebab 5 minit saya jadi macam nervous pula. Okay, so optical and fiber optic sensor, again Dr. Arif did the research in FBG. So FBG is stand for fiber break grating. So fiber break grating against in fiber, you have different indices of different reflective index lah. Okay, so from there also can translate information. Alright, so here we have Dr. Fairuz Diana Ismail. So Dr. Fairuz did synthesis and characterization of cobalt ferrites nanoparticle for photocatalytic degradation of industrial waste. So photocatalytic degradation ni maksudnya we can remove anything that we don't want lah, for example. Okay, for using light. Okay, and then we also have Dr. Maisara Nuralim. Dr. Maisara Nuralim, the research area is about laser application, and mostly she used LIBS, light-induced breakdown spectroscopy. And her current project is about elemental detection. Okay, elemental detection can be silver, gold, okay, using LIBS, and application in food quality assurance, assessment on counterfeit product, and also water quality control. And her second project is about synthesization of metallic nanoparticles by pulse laser ablation technique. See, pulse laser, right? So one of the output that I did produce pulse laser, and this pulse laser can be used by others to investigate other things. Okay. So application can be used in cancer treatment, antibacterial properties, enhancement solar cell quality. Alright, last but not least, we have here Dr. Norain Hussein. So Dr. Norain Hussein is expert in fiber optic sensor, science communication, in STEM, science, technology, engineering, and mathematics education. Okay, so Dr. Norain did project about slow light in optical fiber in her PhD. Alright, so current project now is about optical fiber sensor for gas ammonia, and also Dr. Ain is very active in the science informal learning. Okay, she just secure grant 50K. Congrats Dr. Ain for this project. Alright,
Malu lah saya.
I think that's all from me. Thank you.
Thank you so much, Dr. Nabila. That was a very great and helpful sharing. And I'm sure that it helps the students to understand better in what optics is about. By the way, Dr. Nabila, there is a question from Hafiz.
Okay,
Is there
okay.
any interesting researches about laser that can be used in space?
Sorry?
Is there any interesting researches about laser that can be used in space?
This one also I think have, because is there any interesting research about laser that can be used in space? I don't have. Wait let me think. Laser in space.
Hi, Dr. Bila, can I
I was
add?
thinking about the name in there. Dr. Noaim maybe can help me.
No, okay, no, I don't want to help. I mean, yeah, but it's not, maybe Dr. Bella, while she's still trying to recall the research, I remember I did my master's in Holland, and it's a spectroscopy. I mean, we use, you can imagine interferometer, right? Dr. Nabila, it's a very simple interferometer.
Yeah.
So we can extend it to do the measurement for space. And then there is research during my master study, we use spectroscopy, of course using laser as the light source to determine the displacement in space. So yeah, there are applications that can be used for space in optics. So to answer the question, I think not only in optics, any research group can find their application for space, underwater, darat, udara semua ada, right? You know? Okay, just simple sharing lah.
Okay, thank you. Thank you so much, Dr. Ain.
Doctor.
Okay, any other question?
There is one more question, but it is for Dr. Sarah, but I think you can also answer this. For
Okay.
your research, How long does it usually take to complete those researches?
Actually, research is never end story, because after you finish one thing, there are many other possibility to continue your research. So, sorry. So, but of course, we have target lah for our outcome, right? So for master, normally what we do, we want to investigate the optical properties, for example, for our material. So maybe it took about for master normally maximum 2 years lah to complete your research. Okay, and for PhD it's about 4 to 6 years. Okay, because in PhD in your study is more in details lah what you need to investigate. Okay,
Okay,
sorry because I'm now in the college of, if you hear the background
How about
sound.
Dr. Sarah? Is Dr. Sarah still here?
Apakah cabaran?
What's the question? Is it same with Dr. Nabila?
How long does it usually take to complete those researches?
Oh, yeah. No, same with Dr. Nabila. Normally, we target around 2 years. Or actually, some of students can manage 1.5. That's the fastest way for the student master. And then for the student master, maybe normally they more than 2 years, maybe 2.5 or 3 years. But I think 2 years is the nice duration or period. For the PhD, the fastest is 3 years, but normally people will drag to 4 years and little bit to 5 years. But I think 3.5 years or 3 years is the nice period for PhD. But if you compare to overseas, and if you compare to overseas like Singapore, American, they have like 6 years or 5 years. So for the PhD, they need take class for 2 years, and then if they pass the class, they can proceed to the PhD. So sometimes some field and different field have a difficulty. So sometimes you have like equipment fail, equipment not ready. So some material expensive. So there's so many difficulty in our challenge in our research. So sometimes they only deal with the simulation. So different field and have a different challenge. So you need to you need to investigate, or you need to study the field for the field. So what is the possibility coming before you take the master or PhD? So you know what going to so yeah. And then you need to ready with the challenge, the new things. Nobody knew that thing, so you need to find yourself. Maybe there is not an expertise in Malaysia, so you need to go out looking for overseas. So there so many possibility in research. Okay, depends on the field itself. Okay. But I think materials is the easy one. I think the material is easy. But because of the pandemic itself, it's disturbed so many students. So it's drag so many students. They cannot do the experiment. So that's all. Right.
Thank you, Dr. Sarah. There is one more question for Dr. Nabila, I guess. If fiber optic is something about light, is that mean that all our information are carried by light. I wonder how our internet works. Dr. Nabila, you are muted.
Mute me. Okay, so that's why in light, how do we know the character or the information of the light? Okay, it based on the information that we got. That's why in light, to study the information, we have the spectrum of light. It can be translated into what the power, okay, and also other things for pulse. For example, you can investigate the repetition rate, the pulse width that carried by the light. So it gives the information of the signal, right?
So, thank you, Doctor. And for Dr. Nabila and also Dr. Sarah.
Yes.
So when you are doing your researches and then when you feel like giving up, what do you do and how do you overcome it? And what should they prepare to become a researcher?
Okay. As for me, maybe I can answer first. Okay. So in doing research, I believe, if not in research, okay, in anything that we do, it must have obstacle in there. Okay. So what I'm doing actually look back at your niat. Okay, at what you intend to do, and make your what your loved one as your spirit to move on. Okay, so of course there are a lot of obstacles. It's not easy in study, even in degree level as well, right? So sometimes you find it difficult to understand the things and so on. But then always what you call it, not give up lah. Always find yourself and also do what you need to do. Okay. Any technique to expense. Okay, Dr. Fariza here as well. Okay, that's all from me.
How about Dr. Sarah?
Okay. Okay, honestly, during my research, at the one point, I don't know whether I can pass or fail. So actually, my supervisors always say I will fail this PhD. So yeah, it's heartbreaking, and I don't know I don't know what should I do, and my parents also don't know this happened. So I just keep going, keep writing, and focus what the supervisor said, and believe yourself, and yeah, have faith. So I think I don't know. I think I'm very fortunate to finish my research. So just you need to keep going.
Alright, so seems like we finally reached the end of our program. Thank you very much, Dr. Siti Sarah binti Safai and also Dr. Nabila binti Kasim. That seems to be in an unwell condition, but still proceed to share about the researcher. And then, on behalf of the introduction to physics subject, I would like to invite Dr. Ain to conclude the program.
Hi, can you hear me? Thank you very much, our moderator, Naili. And of course, thank you very much to Dr. Nabila, Dr. Siti Sarah. Tepuk tangan sikit, clap, 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 clap. So, this is as some of you, I already repeat this in the previous session, Introduction to Physics course. We try our best to provide to our students, first year students, about the what you call the branches in physics that we have. Not and of course, it's good if we can understand or know or be introduced to physics that we have in our UTM Sanjungan Basri. So finally, today remark the complete all four research group that we have in our department. Thank you very much. We have Dr. Sarah, we have Dr. Nabila, and then last week we have Dr. Eza and also Dr. Shazwan. And I hope that this gives some general idea to the students. And some students, they might say, not might say, some one student did mention in class before, like, it's okay, we still have 3 years to decide what research interest that we have. Yes, I just feel like it's good for us to give this exposure, and thank you very much to all of our speakers. And I just want to add something because it's quite long discussion. I think it's also due to the previous sharing last week also, how long the research a research take. Then I can say that it depends on, like just now Dr. Sarah, Dr. Nabila mentioned about master students, PhD students, and it can be 7 years, it can be 2 years of PhD. And if you are looking at a smaller scale, smaller timeline, so your final year project actually is only 1 year, like 1 year, like 2 semesters. If you look in smaller timeline, shorter timeline during your third year study nanti. So yeah, it will be like 2 to 3 weeks for one small project, one small research, and then you may start developing research skill, scientific research skill in your lab work. So you have that lab work masa di tahun 1, and then that research skill is needed for you to excel in your third year and also your final year project, and for your future if you continue your study in a research field, not only in university or or research center, but maybe in industry. They need to do some research when you need to convince to the employer that you are still important to the company. Yeah. Okay, so I hope this give a good exposure to all of you, and then thank you for all questions, comments. Kalau minat it's not impossible, best of luck. So itulah, I also kadang I a little bit worry with sharings of all 4 research groups. Some students might think that okay, research is quite complicated. Maybe because you are listening, or you are missing achievement of researchers who already have PhDs. Okay, but trust me, all of us was once a student, kan? So kita bertanya research skill to develop since our first year. So yes, it's complicated, but it's not impossible for you to have the same success. So maybe you will be more successful than all of our speakers, our inviting speakers. So yes, kalau tak susah, tak seronok lah bila dapat, kan? Takkan dapat benda senang je. Okay, so I hope you have dapat get inspired from this series. Thank you again to the moderator, and please congratulate the team. So we have Dr. Salwa here, and then Hazim and Hafiz, abang besar, abang belakang tabir, for helping our technical part. So tahniah, congratulations. Thank you juga kepada all of our moderators, and yeah, congratulations. And we will continue discussing in our introduction to physics courses dengan Dr. Salwa and also saya after this. But feel free to approach all of the lecturers that are being introduced in this series. Okay, so Naili, do I need to remind anything? Oh yeah, the attendance list, the QR code attendance as provided by Dr. Salwa in the chat box for your feedback and also attendance. Okay, ada siapa nak remind apa-apa? Tak ada. Ni pasal kucing lah ni. Alright, thank you very much. Bye-bye. Back to Naili.
Okay, so we would like to present both of our speakers with certificates for joining us today. So next, we are going to have a photo session. So everyone, please feel free to turn on the camera so that we can take the photo together.
Okay, siapa yang ambil gambar ni?
Okay, ready? Okay, 1, 2. Okay, sekejap Okay, one more time. Okay, 1, 2, smile. Okay, thank you. Okay.
By this, we will end our sharing session here, and thank you to all participants, and I hope this session will guide you for your future career, inshallah. That's all from me. Thank you.